Welcome back. Now we will see errors and measurements in Unit 1. Last class we have discussed about what are the static characteristics and dynamic characteristics of measuring instruments. Now we will see what are the errors in a measurement or an errors in measuring device. So in general, errors are classified as limiting errors and known errors. Limiting errors are guaranteed errors that are available in any measuring instrument, not even measuring instruments in any systems. Because as we all know from a second law of thermodynamics, the efficiency of a machine can never be 100%. So we cannot avoid certain errors or certain percentage of quality from any devices. So that lag in the quality, you take it as errors in measuring device, and those errors are called as limiting errors or guarantee errors. The other one is known error. So in general, the measurement errors are classified as gross errors, systematic or cumulative errors, I'm sorry, random or residual or accidental error. So basically there are three classifications: gross, systematic or cumulative, random or residual, or accidental error. Again, the systematic or cumulative error is classified as instrumental instrumental error, environmental error, and observational error. Let us see what is meant by gross error. So gross error, as the name implies, it is not just one particular error. It is a group of error that happens due to human mistakes. So we persons who are taking the readings, when we take it in a wronger manner, or when we do the recordings in a wronger manner, or if we do some mistakes in calculations and we proceed with the same, then those errors are come under the top title gross error. And sometimes the experimenter, that is we, the humans are the experimenters, may grossly misread the scale. That is a major gross error that we face then and there. Example, due to oversight, instead of 21.5 degrees Celsius, they may read it as 31.5 degrees Celsius. So that is a miscalculation. So if the reading is 21.5, for instead of 21.5, if I misread the reading as 31.5, then it is a gross error. If the ammeter shows 2.5 amps, then if I took the reading wrongly as 2.4 amps, then it is a gross error. Okay. And sometimes 25.8 degrees Celsius can be miswritten as 28.5 degrees Celsius. The next one is another gross error made by human is that whenever we take a reading in an measuring device, we have to stand in front of the measuring device and take the reading. So this I observed in labs. When the students are about to take the readings, they will take the readings from a side view. So the scale may seem to point in a different reading, but actually when we get a closer look at the actual value, the reading will be different one. So the position in which we are taking the reading, that also matters most, and that also creates a gross error. The next is systematic error. So systematic error are instrumental error, environmental error, observational error. There are T types. As the name implies, systematic error. So these errors are happened within the measuring instruments. So the first one under the systematic error is instrumental error. So these are error arises due to three reasons: due to inherent shortcomings in the instruments, that is, if the instrument itself is a faulty instrument, even when you purchase the instrument, then it is an instrumental error. If due to misusage of instrument, if I misuse the instrument and then the instrument gets faulted, then it is an instrumental error. And then due to loading effects of the instrument. While connecting the knobs in the measuring instruments, if I load too many wires to the terminals of the measuring instruments, then it calls a loading. Then it affects the loading. Hence, the actual value to be measured by the instrument will get affected because of the high resistance at the terminals. Because when we connect the leads to the measuring devices, you are not supposed to connect so much of wires. You need to connect as less number of wires as possible in order to avoid loading effect. The next error is environmental error. So these errors, as the name implies, are arises due to external factors that causes a deviation in the measuring device. For example, due to high temperature or high pressure, humidity, dust, or due to electromagnetic interferences, there may be change in the measurement value. So these error will constitute the environmental error. The next one is observational error. The error on account of parallax is observational error. So when you take the reading, if there is a mishaps, then it is called as observational error. And the third one in the systematic error is residual error. So residual error is also called as random error. These occurs due to multitude of small factors. So it is not just one error. So it is like a kind of gross error which constitute many small factors which changes or fluctuate from one measurement to another. So the happenings or disturbance about which we are unaware or lumped together are called as random or residual error. Certain times we cannot know the actual reason behind the changes in readings. So that deviation or that mistake may be due to some reasons which are unaware to us. Those errors are called as random errors. Now we will see basic mathematical terminology so that these errors can be easily calculated. So these topics we have already studied. You might have studied these in your mathematics classes, but without knowing the actual application you would have studied. But here is a good here in measurement and instrumentation you can actually find the perfect applications of your mathematics topics which you have studied in your school days. So first let's see what is meant by arithmetic mean. So in general, arithmetic mean is like an average. So it is a measured variable, the average or the arithmetic mean of a number of readings taken. That is called as arithmetic mean. If I give you 10 numbers, you will take the arithmetic mean. Here in measurements, that those 10 numbers will be the 10 readings. And the equations you already know. Next is deviation, arithmetic deviations. I hope you could relate the mathematics topics with the subject now easily. Deviation is the departure or the elevation from the actual value to the measured value. So that deviation can be found from the arithmetic mean. For example, if I find the arithmetic 1, let it be some value, then the deviation will be x1 minus x1, the deviation minus the arithmetic mean. Then deviation 2 will be the x1 minus the arithmetic mean. So if I take a 10 set of readings and I take an arithmetic mean, and if I subtract the arithmetic mean with each samples or sample readings, then I get the deviations. That will show how the equipment responded or how the equipment is functioning. Okay. Next is standard deviations. So standard deviation, this formula is very familiar to us. It is the square root of sum of the individual deviations squared divided by the number of readings. So I am taking deviation of each and every readings. For example, if I have 10 readings, then I will find 10 deviations, and if I take square root of all the sum of the individual deviations divided by the total number of readings, if it is 10 means then it is n, if n is equal to 10, then that will be the standard deviations. So the formula is summation sigma d square by n. It is for only less than 20 observations, 20 readings. If the number of readings is more than 20, then it is summation d square by n minus 1. Next is variance. Variance is somewhat similar to a standard deviation but without a square root. So variance means it is like an average of the deviations. So deviation will be calculated for a particular value, whereas variance will be for a group of value. So that will indicate how the actual value is deviated from the the measured value is deviated from the actual value. Next is probable error. Probable error means, as the name implies, these error will happen in every reading. For example, if a reading, let it be R1, and the reading value is 0.6745 seconds. Probable error means actually the reading will be some 0.67458910, like that. The decimal points will keep on going on, but we will round off the value and take. So by rounding off, we are creating an error. Also, there is another possibility of probable error is misreading the readings. Okay, so if I take a mean value of this probable error, then it is Rm is equal to R1 divided by root of n minus 1. So the proximity, or the probability of getting more probable errors is found by this equation. Now let's solve a problem. So you can, in the previous, if you want to refer the previous slides, you can refer the previous slides, and please note down the formulas, so that now we are going to solve this problem. The following 10 observations were recorded when measuring a voltage. So in a voltmeter, these 10 values has been recorded by conducting an experiment. The thing is that now you have to find the mean, standard deviation, probable error, and range. Take your own time and solve the problem, and please don't scroll down and watch the result in prayer. So just give a try and then compare the answers given in the next slide. Okay, so hope you find this session more useful, and do solve the problem without fail, and please cross verify with the answers. Okay, so let's meet in the next video series with yet another topic. Thank you. Happy learning.